The point-slope form of a linear equation is useful, especially if you're given the slope or if you know the slope and you're given a point that the line goes through. This form is useful in being able to graph that. So the general form for the point slope is y minus y1 is equal to m times x minus x1. Okay, so y stays as a y and x stays as an x, but the y1 here and the x1 are the point that you'd be given. Remember, it comes in xy form. And then the m is just the slope. So, for example, say we're given a line that has a slope of 3, and it goes through the point 8, 4. So we know that x and y is 8, but because it's the point, it's one point that it goes through, that's x1, y1. So let's plug everything in here. So now we know that y minus y1, and here's y1 here, so y minus 4 is equal to m, which we know is 3, times x minus x1, and here's x1 over here, which is 8. Okay, so now we go y minus 4 is equal to distribute here. 3 times x is 3x, and then 3 times negative 8 is negative 24. Okay, now we want to get this into slope-intercept form so that we can graph it, because that is the easiest way to graph it if you know the slope-intercept form. So you add 4 to both sides using the addition property of equality. Those will cancel, and you end up with y is equal to 3x, and negative 24 plus 4 is negative 20. And there's your slope-intercept form. Y equals 3x minus 20. So you already know that the slope was 3 because they told it to you over here. But this just confirms it when you get 3x here. And then the y-intercept is minus 20. Okay, so if you graph that, it would look something like this. We know that the y-intercept is at minus 20. There it is right there. Here's minus 20. We know the slope is 3. We also know that it went through the point 8, 4, which we had given you previously. Okay, so 8, 4, well, there's 5, 10, so 8, 4 would be about right there. Okay, but if we take the slope of 3, it would go through that point and it start at negative 20, and that's what that line would look like. So that's how you go from the slope, from the point-slope form to the slope-intercept form. Because remember, from the slope-intercept form, that's the easiest way to look at an equation and go directly to a graph. Now, the thing to be careful of is when you have a point with negative numbers in it. So say the slope is minus 4, and the point goes through negative 3, negative 2. Okay, so when you put that in your point-slope form, it's y minus y1, and this is y1 here, so y minus negative 2 is equal to m, which is negative 4, times x minus, and here's your x1, negative 3. That's where you need to be careful when you start getting negative numbers, because y minus negative 2 up front here is really the same as y plus 2. Negative 4 times x minus negative 3 is the same as x plus 3. Remember, when you're subtracting a negative, you end up adding. So now it's y minus 2 is equal to negative 4x minus 12, just by distributing negative 4 times x and negative 4 times positive 3. And then you add 2 to both sides to get the y by itself. And you end up with y is equal to minus 4x. Minus 12 plus 2 is minus 10. Okay? So that's the one thing to be careful of, is when you have negative numbers, you just need to be really careful how you take those into account here and make sure your math is all right. If necessary, use a calculator to make sure you're getting those numbers right. And that's how you do that.